Welcome to day 17 of our high level design series. Today we will be diving into the topic of data flow and state management in distributed systems. We will explore how data moves through components and how state is maintained across different services. Let's start by understanding the key concepts. Data flow refers to the movement of data between system components, while state management refers to how a system tracks and synchronizes its state across services, especially in a distributed environment. One of the first things we need to do when designing data flow is create data flow diagrams or DFDs. These diagrams visually represent how data moves through the system. Additionally, using a layered architecture helps in organizing the system. For example, the presentation layer, the business layer, business logic layer, and the data access layer, where each layer has a distinct responsibility. A pipeline architecture such as ETL, extract, transform, load, also helps ensure a smooth data flow. Next, let's differentiate between synchronous and asynchronous data flow. In synchronous data flow, tasks are executed in a sequential manner with an immediate response expected. This is great for real-time data updates. On the other hand, asynchronous data flow allows tasks to run concurrently, ideal for event-driven systems like when using message queues. An API gateway plays a critical role in managing data flow in distributed systems. It acts as the central hub, routing requests to appropriate services. It helps centralize control, making it easier to manage traffic between different components of the system. Now let's discuss state management. In stateless systems, there's no memory between requests, which makes them scalable but limited in scenarios like user sessions. In stateful systems, state is retained between requests, which is useful for maintaining user sessions, shopping carts, and other long running tasks. When we talk about session management in stateful systems, we commonly use methods like JSON Web Tokens or JWT and session cookies. These store state information such as user sessions, which are then retrieved on subsequent requests. This helps ensure continuity for users across multiple interactions. Event sourcing is a pattern where every state change in the system is captured as an event. This allows us to rebuild the system state at any point in time. Coupled with CQRS, command, command query responsibility segregation, we separate commands from queries, optimizing read and write operations to better suit different use cases. To enhance performance, distributed caching solutions like Redis and Memcached can be employed. These caches store frequently accessed data closer to the user, thus reducing latency and improving response times for critical data requests. Data replication is a key strategy for ensuring high availability and fault tolerance. By duplicating data across multiple servers, we ensure the system remains operational even if one server fails. About consistency, we have models like eventual consistency, strong consistency, and the Cape theorem, which addresses trade-offs between consistency, availability, and partition tolerance. For managing stateful services, orchestration tools like Kubernetes stateful sets are critical. They allow for the proper management of services that need to maintain state while ensuring high availability and consistency across the system. Message queues such as Kafka and RabbitMQ are great for handling asynchronous state updates. They allow services to trigger events which propagate state changes across various components of the system. This ensures that the system remains consistent while decoupling services. While implementing data flow and state management, we face several challenges including latency, consistency, error handling, and scalability. To mitigate this, we often use parallel processing, retries, circuit breakers, and horizontal scaling to keep the system running smoothly even under heavy load. In conclusion, managing data flow and state is crucial to the success of distributed systems. By using tools like caching, API gateways, and event driven architecture, we can handle complexity and build scalable, reliable systems. Proper data flow and state management ensure that services operate cohesively and efficiently, delivering a seamless user experience.